Hi everyone, and welcome back to Cloud BI Academy. I hope you are doing great and practicing regularly. Today's session is extremely important, and I'm not saying that casually. Today we are stepping into something that separates beginners from professionals. Let me ask you something. If I ask you to build a banking system or a school management software or an e-commerce application, can you build it using only functions? Technically, yes, but professionally, no. And that is why today we are learning object oriented programming in Python. If you understand this lecture properly, you will never look at programming the same way again. So stay focused till the end. These are the topics today we have covered: oops, real life examples, creating first class, and then object creation, constructor, and many more things. So let's start simple. Okay. So the big question, what actually is OOP? Okay. It stands for object oriented programming. Up until now, you might have been writing code that reads like a recipe, step 1, step 2, step 3. That's procedural. OOP is different. It organizes code into classes and objects. Think of it as a modeling real world thing in your. It makes your software reusable and scalable. If you are building a massive system like Amazon or Netflix, you can't just have one long script file. You need OOP to manage that complexity. Let me ask me one question. Has anyone here tried to write a script that got so long it became hard to read or fix? That's usually the sign you need OOP. So emphasize that OOP isn't a new language, just a different way of structuring Python code. Let's use an analogy that always clicks. Think of a car factory. Before they build a car, they have a blueprint. And that blueprint is not a car. You can't drive the blueprint. In Python, that blueprint is the class. Now, when the factory uses that blueprint to create an actual physical car, that is the object. And the car has properties like color, brand, and speed. Those are attributes. And it can also do a thing like start or stop. So those are methods. So we create the blueprint once, but we can build thousands of distinct car from it. Now we will understand this in a technical way. Class, the template blueprint, doesn't take up memory space for data yet. Object, the actual instance created from the templates. Attributes, adjectives describing the object like a red, color is red, speed is fast. Okay. And method, that is an action the object can perform. Like we have drive, we have brake. Okay. So enough theory. Let's write some code. Open up, understand this in a better way. So we are going to define our first blueprint. In Python, we use the keyword class. By convention, we capitalize the name of the class like student. For now, we will just put the pass inside. So so this pass basically which tells Python
I'm
I'm
here
not ready
yet,
to
but
put don't give me an error. So this defines the structure. It exists now, but it doesn't do anything yet. So basically, this placeholder we keyword to avoid error in empty classes. So this code run without output, but it successfully defined the blueprint. Now that we have the student blueprint, okay, let's admit some students. We create an object by calling class name like a function s1 student. So s1 is now an instance of student. Here is a cool part. I can make s2 and Python create a completely separate object in a memory. They are both student, but they are totally independent, just like a two different car coming off the assembly line. So now the question is, if I change a variable inside S1, it means if I have changed here the variable, will it affect S2? So our answer is no, because they have unique memory. Okay, now I can run that one and I can show the data. So we are getting two output. This is our first output and this is the second output. It means different addressing of the output. Now let's move to our slide. So this is the creation of first class. Class is equal to blueprint and object as instance of class. Okay, you are aware about that. Creating object s1 is equal to student. Is object has unique memory. Multiple object can be created. It means we have already shown you example. S1 is equal to student and S2 is equal to student. Okay. Now next move to constructor. So right now our student are empty. We need to give them data immediately when they are created. So we use a special magic method called init. So this stand for initialize. It run automatically the moment you create an object and you don't call it manually. Think of it as a setup wizard that runs when you install new software. So we define it like this. I can show you one. Def init self name and age. We can say that creating a method, or we can say that in a simpler word, new student is. So we will show how to store these variable into in the next slide. So student often forget the double underscore before and after init. Make sure they type init, not okay. The click S1. So after constructor, we understand the self keyword. Now let's talk about the elephant in a room. Okay. And self beginners often find this confusing. Imagine I hand you a blank name tag and say write your name, and you write it on your tag, not on mine. So self act like that tag. It allows the code to distinguish between this specific object's data and another object's data. When we say self.name is equal to name, we are saying save the name value into this specific object's memory. So let's go our code and I can show that. So for example, I can remove this one. Self.name is equal to name and self.age is equal to age. Okay. As well. So it is printing the name, first name Sachin and second for getting the Rohit. So we have a understand this concept and we have attribute like a name and age. Now let's add behaviors. In OOP, function inside a class are called method. They define what the object can do. Let's create a greet function. Greet method. So our code I can change here. So these two are attribute. So this is your class. Okay. These are the attributes. Now add the behavior. So def greet self and print my name in. We can add the behavior here. So this is the perfect example. And now we after self keyword we understand the at, we have understand the attributes method where variable inside class and function inside class, this that part. Okay, these are the attributes. Now go understand the encapsulation. So now we enter the professional territory. The pillars of OOP. First up is encapsulation. This is about security. Imagine a bank account and you shouldn't be able to manually reach into the database and set balance is equal to 1 lakh and we want to protect that data. In Python, we can simulate private variable by adding two underscore balance. This make it harder to access from outside the class. We then provide getter and setter method. to control access safely. So for that one, I can show you one example here. For example, we create a one new class bank, bank account, and here we have defined init self account number, like a self function account number and balance. And here we have created the self dot account. So this is the normal variable we are creating. Okay, but if we so this is your private variable. Okay, so you know that like encapsulation using a single underscore. Okay, so we can private variable, we can say that. Okay, so after private variable, understand the getter method to access this private data safely. So remove that one. So get balance. Okay, and it is return self dot underscore balance. And so before that, I can show you some better way. So for example, this return self your here we have access private data safely, and I can do account like bank account number this and 1000 and account dot get balance. Okay, so this work and we get the output this 1000. If we change the amount like 1 lakh, so we are getting that part. And one more thing I can show you here. If we doing this print acc dot underscore balance, so this would thrown the error because it was protected. Okay, it is not recommending thing. So this is just for your knowledge. If you directly call private variables, so we getting error. Okay, so this is the thing for encapsulation. Now understand the second pillar, that is our inheritance. So this is the ultimate tool for laziness in a good way. It prevent code duplication. Imagine we have a person class with the name and age. So I can create a class person. Okay, so Imagine we have a class with a name and age, and now we need a teacher class. Teacher is a person. Instead of rewriting the name and age logic, we let teacher inherit from the person. So how we can do that? Now child class inherit from the person. So how you can create a teacher? No need to it is creating confusion. 1 second, I can remove that one. Simply I can write teach self. So this is this grid. Okay. So this grid is inherited from the person, and this teach is defined in a teacher. So the teacher class get all the attribute of person for free, and then we can add a specific thing like subject or salary. So we have understand encapsulation, inheritance. Now we move to our next important thing, polymorphism. So the third pillar is polymorphism. Poly means many, morph means form. It means poly means many and morph means forms. It allows different class to have methods with the same name but different behaviors. Think of a dog and a cat. Both can make a sound. If I call dot sound on a dog, it barks. If I call dot sound on a cat, it meow. So Python figure out which one to use automatically based on the object type. So understand the polymorphism. I can create some example here. So for example, I can create a class for a dog. I can remove this def sound self of okay, and one create a class for cat. So animal dot sound it means same method name, and if you go through here, same method name, different result. Okay. So after polymorphism, understand why OOP is important, our object-oriented programming. So why did we learn all this? Because this is the industry standard. If you want to use popular framework like Django or Flux for web development, they are built entirely on our classes. If you work on enterprise apps, you need OOP to make the code maintainable. It allowed team to work together without breaking each other code, and object-oriented programming makes large projects manageable. If talking about maintainability, easier to fix bug in one class than in 1,000 lines of code. Framework you cannot effectively use Django, Flask, Pandas without understanding objects. And it is expected in almost every developer job interview. So let's recap what we conclude today, we learned that a class is a blueprint and object is the instance. We learned that underscore init underscore sets up our data and self point to the current object. We should cover the whole trinity of object oriented programming, encapsulation for hiding data, inheritance, sharing code, and polymorphism, flexible behavior. So you have taken a huge step today. In our next session, we will tackle exception handling, how to stop your app from crashing, and file handling. And so, if this session helped you, like this video, comment your doubts, share with your friend, and subscribe to Cloud BI Academy. In the next class, we will go even deeper. Maybe we can say they're already showing that exception handling, file handling. Okay, so you tell me in the comment. Thank you for watching. Keep learning, keep growing, and I will see you in the next lecture. Thanks. Bye bye.